All right, welcome to week 11. We're actually starting a new unit in this week. It's on randomness and data, and what that really involves is an awful lot of probability. And so we'll be investigating probability for most of the rest of the semester in one form or another. And so this week we're just going to do an introduction to probability. Okay, and this video is designed just to give some very basic terminology and the way we think about probability. Okay, so first place I want to start is with some questions from the beginning of the topic in the book, topic 11. Right at the beginning of the section, there are 4 questions, and I want to look at questions 2, 3, and 4. Okay, so here's question 2. And if you haven't answered it yet, just think about it and then see what you think. All right, if 4 people in a crowded elevator get their cell phones mixed up and they decide that each of them is going to take a phone at random, then do you think it would be more likely for everybody to get the right phone or for nobody to get the right phone? Okay, think about that and decide whether one is more likely or if you think they're equally likely. All right, kind of getting at the idea of probability, likelihoods. All right, question 3 is similar. If 4 people in an elevator get their cell phones mixed up and they each take one at random, do you think it's more likely for exactly one person to get the right phone or exactly 2 people to get the right phone? Okay, or do you think they're equally likely? Okay, so once you have your answer, let's look at the 4th question there. All right, different scenario. Suppose a couple has 4 children. Which gender breakdown do you think is more likely? 2-2, so 2 boys and 2 girls, or a 3-to-1 gender breakdown one way or the other? Okay. All right, do you think a 2-2 breakdown or some version of 3-1 breakdown in genders is more likely, or do you think they're equally likely? Okay. All right, those 3 questions we will have the tools to answer very specifically by the end of this topic. Okay. All right, but this idea of likelihood is probability. All right, so let's be specific. Let's be really formal. What is probability? The probability of some random event is the long-run proportion of times the event would occur if the random process were repeated over and over again under identical conditions. Okay, so when we're thinking about probabilities, we're thinking proportions. So probabilities, like proportions, are between 0 and 1. Okay, so 2 simple examples. Tossing a coin, right? You can talk about the probability of throwing heads, or rolling a die. You can talk about, well, what's the likelihood of tossing a 2 when you roll a 6-sided die, right? Okay, so I just want to look at those 2 examples in this video briefly. All right. And the reason I want to look at them is there's really sort of 2 fundamental ways that we calculate probabilities. Number 1, we can do simulation, okay? And what I mean by that is we can just do empirical estimates by experimenting. We can, if I want to know what's the probability of tossing a heads, well, let's throw a coin a whole bunch of times, right? Okay, so let's do that. All right, I'm going to switch cameras here. All right, I got my coin there. All right, and what I'm going to do is I'm going to throw the coin many times. Well, I'll throw it a few times, and we can think about that as a way of estimating the probability of throwing a heads. All right, you might already have in your head what the probability of tossing a heads is, but we're going to do this by simulation. Okay, so all right, so let me throw it 10 times. Okay. So there's 1, that's a heads. 2, another heads. Oh, that one rolled off, but it was a tails. That one rolled again, and that's heads. So that's 3 out of 4 heads. Okay, tails. So 4 out of 6, 3 out of 5 heads. There's 4 out of 6 heads. Tails, 4 out of 7 heads, 4 out of 8 heads, because that was tails, 5 out of 9 heads, 5 out of 10 heads. Okay, so in 10 trials, we had 5 heads. So empirically, we estimate the probability of getting heads is 5 out of 10 or a half. Okay? It's an estimate though, right? So if I don't know anything about the theoretical probabilities, and I haven't tossed it very much, I could have easily gotten 6 out of 10 heads, or 4 out of 10 heads, or 3 out of 10 heads, right? But that's the empirical estimate. Okay. You can do long term. Let me switch back my cameras. Computers are great ways of doing simulations. Right. So let me. At a website here called Shodor, and they allow you to do lots of coin tosses pretty quick. So, for example, here's my head. I can say I'm going to toss a coin 100 times. Toss it. Okay, so doing my 100 tosses. There are my tosses. Okay, and if I want a table of the results, there's. I had 57 heads in 100 tosses, and so the empirical probability, right? The empirical probability of getting heads based on that simulation is 57 over 100, right? So switching back. Switch back here. There we go. Switching back with my computer simulation. I should really use approximately here. Okay, so according to that computer simulation, my likelihood of getting heads is 57%. Okay, we can do the same thing with a dice roll if we want. Right, so if I want to do a simulation with a dice roll, I want to find the likelihood of getting a 2, so I'm going to roll my die 10 times. 1, 2, 3, 4, there's a 1, 5, 6, 7, there's my 2, 8, 9, 10. All right, so in 10 rolls, I had 1, 2. So the probability of rolling a 2 is approximately 1 in 10, or 0.10, or if you like percents, you could write it as 10%. Okay? All right, simulation. All right. Okay, so that's one way that we can calculate probabilities. The other way to do it is we can calculate theoretical exact probabilities. Okay, so in situations where the outcomes are equally likely, that's important. When we're in a scenario where the outcomes are equally likely, what we can do is we can list all the possible outcomes and then determine the proportion that corresponds to the event of interest. And the set of all possible outcomes, we call that the sample space. So here's the plan. Okay, we can calculate theoretical probabilities by listing the outcomes, and then, important, if the outcomes are equally likely, then we can find the proportion that correspond to our event of interest. All right, so let's talk about our coin tossing again. Right, All right. When I toss a coin, so this is the theoretical. Okay. I'm going to write my sample space. It's a set of outcomes. If I toss a coin, there are two outcomes, right? I can have a heads or I can have a tails. Right? And which one are we interested in? We're interested in the heads. So the probability of getting a heads is 1 out of 2, right? One option out of the 2, right? And that's our theoretical probability of getting a heads, right? Makes sense? But that's our framework, okay? Do the same thing with the dice, right? If I do the theoretical, okay, my sample space, okay? So if I roll a die, what are the options? I can get a 1, a 2, a 3, a 4, a 5, or a 6. And all those are equally likely, right? So the probability of getting a 2 is 1 out of 6. All right. Okay. Now we want to be, like I said, I want to be really careful about the sample space. We really want to have equally likely outcomes. Like you would not, okay, you would not write your sample space like this. Right, where my two outcomes are 2 and something else, all right, 2 something other than a 2, right? And the reason we wouldn't write it like that is because these are not equally likely. Right, you're much more likely to get something other than a 2 than getting a 2, all right? Okay, so that's our plan. That's the approach we're going to take, but we're going to look at some more complicated scenarios, okay? And those are the activities in topic 11.